Now on to example 5. We're rationalizing by conjugates using the same method that we did in the previous 4 examples, except now we have something more complicated to worry about. We still have radicals being added in the denominator, so we're going to have to use conjugates in this case. It's just going to be kind of nasty, and hopefully this time I won't run out of room on my board. So how do we do this? Start all the way at the left, because I'm going to need all the room I can get. Root 7 minus 1 over 2 root 7 plus 4 root 2. Okay, the idea again is to multiply these using, multiply by 1 in a clever way so that I can use difference of squares to cancel out stuff here in the denominator. So what we're going to do is multiply by the conjugate of the denominator here. So I have a plus here. I'm going to multiply top and bottom by the negative version of the second term. So I have 2 root 7 minus 4 root 2 over 2 root 7 minus 4 root 2. Okay, close off everything so it's clear that we're multiplying and having to FOIL. And continuing on with now we have to FOIL everything. The top is going to FOIL as follows. We're going to take this root 7, multiply it to both of these guys, and add it together. So we have root 7 times 2 root 7 minus 4 root 7 times root 2. I changed up the order of multiplication here a little bit, but no big deal. It's the same thing. So then that finishes up this first thing. I multiplied this times this and this. We're good. Minus 1 times this and this. So we have minus 2 root 7 minus 1 times minus 4 root 2. That gives me plus 4 root 2. And now I've completely FOILed out the top. That's horrendous. Hopefully it'll simplify. It probably will not. But sometimes that's how things go. So now I have this guy times, I have this whole thing times this whole thing, but it's conjugate. So the idea here is to use a difference of squares. So it's literally going to be this guy times this minus this times this. Writing that out, I have 2 root 7 squared minus 4 root 2 squared. Okay, now let's simplify the top as much as possible first, because that's nasty and I don't want to rewrite that 38,000 times. And I'm sure you don't either if you're following along and keeping notes. All right, so here we have all these things being multiplied together in this first term. I have 2 radicals, namely, being multiplied together, so I can combine them under the same radical. So I have 7 squared inside just one radical, and I have a 2 floating out in front. So I have 2 times root 7 squared. All I did was combine these 2 radicals into 1. Okay, and you multiply the contents of the insides. Similarly, I do the exact same thing here. So I have minus 4 putting these 2 things inside the same radical, so 7 times 2. Here I don't have any extra radicals, so I'm stuck with 2 root 7 and 4 root 2. Just carrying them along for the ride. So that didn't really simplify things too much, unfortunately. So we're kind of in a precarious spot right now in terms of space. But, okay, maybe we can simplify the bottom. Maybe that'll help us clear some things up later. So looking at this, I have 2 root 7 squared. Using the power rule for exponents, or the product rule rather, it's the same thing as if I took the second power of both of these things and multiplied them together. So this is the same thing as 2 squared times root 7 squared. And we can do the same thing over here. So apply this 2 power to each of these guys. So you have 4 squared times root 2 squared. Okay, simplify. Oh boy, I have to rewrite the top, don't I? Well, square root of 7 squared, well that's just 7, thank goodness, so we can simplify a little bit. 4 times square root of 14 minus 2 root 7 plus 4 root 2. All over, okay, 2 squared is 4. And then square root of 7 squared, that's just 7. Then we have minus 4 squared, which is 16. And then times square root of 2 squared, that's just 2. So that's 32 here, and that is going to be 28 here. So rewriting, 2 times 7 is 14, minus 4 root 14, minus 2 root 7, and plus 4 root 2. Okay, that's the numerator. And then denominator, as I said before, this is going to be 28 and minus 32. So that gives me minus 4. Okay, so now I have a minus 4 in the denominator. And I wonder if I can simplify or cancel something out here. So I have a 4 in the denominator, which is just 2 times 2. And in 14, I have 2 times 7. I have a 4 here, that's divisible by 2. 2 is divisible by 2, and 4 is divisible by 2. So I'm going to factor a 2 out of everything here. I'm going to factor 2 out of that and cancel them. I'm going to do that all in one step, if that's all right. So this becomes 2, and then 7 minus 2, root 14, minus root 7, because I pulled the 2 out of it, plus 2 root 2, all over minus 2 times 2. So here I can cancel off the 2's, leaving me with this horrid expression over root 2, over minus 2. The only other thing you can do at this point, because we've canceled off all the possible 2's, we have a 7 here, which isn't divisible by 2, so we can't cancel this 2 off any further. And no, you cannot cancel it with this 2 or this 2 because you have addition. The only way you can cancel over division like this is when you have things being multiplied. Here we have things being added and subtracted, so we can't just kill off a random 2 wherever we please. Okay? They'd have to be multiplied, just like this 2 was. It was being multiplied, so we canceled it. Okay? The last thing I can do is this negative can go on top. Okay? Doesn't matter what part of the fraction a negative lives at, so I can have a minus this whole quantity, or I can take that minus sign and just push it to every single term here. I'll do that in one step. So we have 2 in the denominator, no longer a negative, and I take the negative and I apply it to every single term, switching the signs. So I have minus 7 plus 2 root 14 plus root 7 minus 2 root 2. So I did was take the negative 1 that was down here and I distributed it across the top because it doesn't matter where that negative 1 is. So this is a really, really complicated solution, but it's because we had a complicated problem to start with. This one up here at the very top. All the complicatedness came from just foiling, but the process of conjugation and multiplying by the conjugate remains the same. This is the core strategy. So you see radicals being added in the denominator, and you have a plus between it, multiply top and bottom by the minus version. Then simplify. Like all this craziness is just a result of simplification. Okay? But the core strategy was right up here. Multiply by the conjugate top and bottom. Okay? Hopefully you found this video helpful, and I will see you in the next one.